Okay, so let's start. So today we are discussing simple interest and compound interest. Another topic which is very straightforward, extremely formula based, and there are very few question types first of all. So the idea here is to understand all the formula really well and then solve a lot of questions of each of the question types so that you are very familiar as to what exactly needs to be done in what kind of question. So I'll not be discussing all the concepts first. So the way normally we do, what I'll do is we'll take one concept, we'll discuss the concept, and then we'll solve one or two questions based on that concept so that it becomes clear to you guys. So first of all, I'll start with the basics of simple interest. So what we mean by simple interest. Okay, so let's say now you want some money, you need fund for some purpose, and you go to your friend. Now your friend is saying, let's say you want 10,000 rupees. Now your friend is saying, I am ready to give you 10,000 rupees, but since I'm giving you 10,000 rupees, which I could have used for some other purpose, I want you to give me some interest on it. So you say that, okay, take 10,000 rupees for 1 year and then give me, let's say about 5% of that 10,000. So this interest is calculated on the principal. So the sum that you borrow is called principal. The interest is the rate of interest. So it can be some 5% or 10% or whatever rate of interest. Time period is given in years. And if it is not given in years, if it is given in months, make sure that you convert it to years first and then use it in the formula. So let's just quickly look at the formula first as to what the formula is when it comes to simple interest. So simple interest is, so principal is given as P. Time period, in some of the books you may find T, or in some of the books you will find N. So I'll use N, and rate of interest is R. So SI is calculated as P into N into R upon 100. Okay. So very simple formula to remember, just multiply everything, principal, the rate of interest, the time period, divide it by 100, you get simple interest. So is that the final amount that you have to pay at the end of whatever period? No, because this just gives you the interest. So principal plus interest gives you the final amount that needs to be paid. Okay. So let's take a simple example and let's see if you guys can solve it. In case you haven't written down the formula, it's the simple interest is P into N into R upon 100, where P is principal, N is time period, and R is rate of interest. Multiply that, divide it by 100 to get simple interest. You add it to the principal to get the amount at the end of 10 years. Try this one. So in case you're joining for the first time, use the chat function to give us your answer. So if you already solved the question, if you know the answer, use the chat function and give it to us. Okay, so how can we solve this question? Now, there are two ways in which you can solve this, first of all. So you need to understand that this 12,500, which is given, is the principal, and it amounts to 15,500. So this is the amount, and your time period, which is N, is 4 years. Now you need to find rate of interest. So the first thing that we have is we need to know that principal plus interest gives you the amount. And now you have 12,500 plus the interest, which is giving you 15,500, right? So the difference that is there is the interest, of course. So the interest that we have got in this period is 3,000 rupees. And now you can use your formula, which is SI equal to PNR by 100. And in this, I just have to substitute now. So 3,000 is equal to the principal, which is 12,500, into N, which is 4, into R, which is what we're supposed to find, divide this by 100, right? Now this will cancel. So of course you have now 500 here. So 500 this side into R is equal to 3000. Hence R is 6, right? So as two of you have already answered, this is 6% as rate of interest. Now, we can look at this from other point of view as well. And there's another way of solving this question, which doesn't involve you writing the whole SI is equal to PNR by 100 formula. So let's quickly look at how you can solve that. Now, you know the difference that is there, which is between the interest, the principal and the amount is the interest. So the interest that has been received is 3000 rupees, right? Now, one thing that you need to remember about simple interest is that unless you are changing the rate of interest every year, the actual value of the interest remains the same. Okay. So in this case, the interest that is being calculated in the first year, or the second year, or third year, or fourth year, that is going to remain the same. Which means that I just need to divide the interest that I've got by the time period. So 3000 by 4. So this will be 750. So 750 is interest of 1 year, right? And this 750 is being calculated on the principal of 12,500. So now I just need to find this and multiply this by 100 to get rate of interest, right? So if I just simplify this, I'll get this as 6%. So this is the same thing that you're essentially doing when you're using the SI is equal to PNR per 100 formula. This is a slightly better way of doing it because it doesn't involve a lot of writing. So you find the interest, divide it by N, and then multiply it by 100 to get R. Okay. Let's go to the next one. So try to solve this using the method that I just did, because that will be convenient to do. Okay, Akash has asked a doubt whether this method is applicable to CI also. No, because we'll come to CI, then at that time we'll see how CI works. Because CI is compounded, so the interest that you get on that you are calculating the interest of the next year and so on. So we'll solve the SI question first, we'll come to CI. Okay. Yeah, I think most of you have got it right. So I can see a lot of 15,000 as the answer. So let's see how we can solve this. Now, in this case, what you can do is, and of course, there are other ways of solving the same question. So you can use SI is equal to PNR by 100 and get this answer. But to calculate this very quickly, what I'll do is this is 5400 interest and the time frame is 3 years, right? So I just need to find what's the interest for 1 year. So 5400 by 3, which is 1800, is the interest for 1 year, right? Now, this interest is being calculated at the rate of 12%. So 12% of something is 1800. So the only thing that I need to find now is if 1800 corresponds to 12% of something, what is 100% of it? So which is nothing but 100 into, I'll just cross multiply 1800 by 12. So if you remember, 12 into 15 is 180. So you'll get 150 here, and that will give you 15,000 as the answer. Okay. So what I did was just look at the interest, find interest for 1 year, and whatever rate of interest. So you're basically finding 12% of something, which is 1800 as the interest. So what is 100% of something, which is nothing but the principal. Okay. So this is one way in which you can solve this. Of course, if you do PNR, you will get the same answer. Try this one. So if it is not clear, the first one is 4% per annum and the second one is 25 by 4% per annum. Okay, so it's 25 by 4% per annum. So far, I've got four different answers to this question. So there's a trap in this question, first of all. The question says find the gain of 1 year by Sachin, and it doesn't ask you to find the gain of 2 years. The question, the whole thing is happening for 2 years, but the question is find the gain of 1 year by Sachin. So that is something that you'll have to do. So people have got 225 as the answer. Just a small tip that read the question carefully. So gain of 1 year, you just have to divide it by 2, and that will give you the answer as 112.5. So let's see how we can solve this question. Now, if you try and understand what exactly is happening, so the difference in interest is what you're supposed to find. So he would have got some interest by investing it at 4%, and he would have got some interest by investing it at 25 by 4%. So the difference is what you need to find. So if you invest 5,000 for 2 years at 25 by 4, you will get some interest. Then you invest, say, 5,000 for 2 years at 4%, you will get some interest. And the difference is what you're supposed to find. And now, what we can do in this case is instead of finding the actual value of each of these calculations, I can simply take away 5,000 into 2 common, right? So I have the 2.25% difference inside because 25 by 4 is 6.25%, right? Now I need to find it for 1 year. So even this 2 years that is there, this I need to divide it by half outside because I need to eliminate. So instead of that, I'll simply remove it because if I divide it by half, I'm basically multiplying by 1. So this question is only find 5,000 into the difference between this percent and this percent, right? So 6.25 and 4, which is going to be 2.25, and divide this by, of course, 100. So what the answer will be, that is what we are supposed to find. So simply this is going to be, if you solve this, this is going to be 50 into 2.25. So 50 into 200 plus 1/4 of 50, so 12.5. So 112.5 will be the actual answer. Okay, so instead of finding the actual calculation of this and this, we are simply taking out 5,000 common, 2 common, then taking the difference between the rate of interest and then arriving at the answer, dividing it by 2, which I did in the beginning itself. So that's how I'll get 112.5 as the answer. Okay. Now coming to the next concept, which is, so simple interest is very straightforward to understand. SI is PNR by 100. Every year interest remains the same unless you are changing the rate of interest in between. Compound interest. Now let's understand how it works. So in a lot of books, you will see the formula for compound interest given as A is equal to P into 1 plus R upon 100 raised to N, right? Now, why is it raised to N is something that you need to understand. 1 plus R upon 100, when they say, basically they're finding at R, which is the rate of interest, what will be the interest, and that is added to 1 because 1 is nothing but the principal. So this formula, which is raised to N, works only when the rate of interest is remaining same. For example, if I tell you that at compound interest for 10% at 10% for 3 years, okay, so then I can use A is equal to P into 1 plus 10 upon 100 raised to 3 because my time period is 3 years and my rate of interest is 10. But in case there is a question where it says that though there is calculation at compound interest, the rate of interest is changing every year, then you can't do raised to n. So if I say the rate of interest is 10%, 20%, and 30%, right, at compound interest, the answer, the final amount, is going to look like this. So first year it will be 1 plus 10 by 100, which is the rate of interest. The next year it will be 1 plus 20 by 100, and the next year it will be 1 plus 30 by 100. So the raised to n thing is applicable only when rate of interest remains the same. That is one. If rate of interest changes, you'll have to use the each of the 1 plus r upon 100 components in a different way and then multiply them to get the answer. So we discussed percentages, and that time we did successive percentage change. So this is a classic example of successive percentage change only. So if I tell you that somebody's salary is increasing by 10%, 20%, 30%, what will be the salary? Effectively, you're trying to find the same thing. So if I tell you that, okay, P is 10,000, it will be 10,000 into 1.1 into 1.2 into 1.3. Okay. Now, the formula, you need to remember this, that the formula gives you amount and not the interest, which means that the amount that you get, you need to subtract the principal from it to get the interest. Okay. So, what is the difference between SI and CI? So, in simple interest, P remains the same. So, every year when you calculate the interest, so the rate of interest can always change, but principal remains the same. So you'll always calculate. So if you're starting at 100 rupees, you'll always calculate the interest on 100 rupees. But in case of compound interest, what happens is P changes every year if there is annual compounding. So P will change every year. So you will start with some principal. Let's say first year you get some interest. So which means that for the first year, A1 will be P plus I. So this A1 becomes principal for the next year. Okay, and we'll take a small example to understand this, and that will get more clear. So this amount at the end of every year becomes principal for the next year, is what you need to remember. Also remember that for first year, if the time frame is only 1 year, there is no difference between simple interest and compound interest. They will be same, exact. Because what you do here, when you calculate A is equal to P into 1 plus whatever, R upon 100, if you simplify this, you will get nothing but P plus NPR by 100, because the time frame is 1 year. And hence, there is no difference between SI and CI if the time frame is 1 year. Okay. So let's take a small example and see how SI and CI will look. So if I start with, say, SI, I'll be writing CI on this side. First year, what will happen is, on principal 1000, R is 20%. So in this case, you are going to get 200 rupees. So interest will be 200, and amount at the end of first year is going to be 1200. In case of second year also, the interest, the actual value of the interest is going to remain same, because you're always calculating 20% of 1000, and hence amount at the end of 2 years. So you'll get 200 of the first year, 200 of the second year, so 1400 in total, 400 in total, so 1400 as the amount. And in third year, this interest is going to be again 200, so A3 is going to be 1600. So that's how simple interest will work. But in case of compound interest, first year is of course going to remain the same. There's no difference whatsoever. And A1 is also going to be same as the A1 for SI, which is 1200. Now the difference will start coming here, because for the second year, 1200 is the principal. Now 1200 is principal, and you're calculating 20% of 1200, okay, which is going to be 240. So the interest will be 240, and the amount at the end of 2 years is going to be 1200 plus 240, which is going to be 1440. Okay, I hope this is clear to you guys, because you need to understand this really well, as in how we are calculating this, because if you don't understand this, it will be very difficult to continue further. So 200 will be calculation for the first year. After this, the amount that gets created by adding principal and interest becomes the principal for the next year. So this 1200 will be P for the second year. Now 1200, so you just need to find 20% of 1200, and that will be this, which is the interest. And P plus interest is going to give you the amount at the end of second year. Okay. Now for third year, principal is going to be 1440. So this will be principal for next year. And again, you need to find the interest, which is 20% of 1440. So 20% of 1440 will be either you can find into 20 by 100 or straight away 1440 divided by 5. And that will be 144 into 2, which is nothing but 288. Okay. So this will be interest for the third year, and the value of amount, which is amount at the end of 3 years, is going to be summation of this and this. So which comes to 1728. Okay. Now, what you also need to understand is the interest, the pattern that is being followed by interest, which is this, this, and this. So interest for the first year is simply 200. The next year it is 200 into 1.2, because rate of interest is 20%. So 100 plus 20 is 120%. So 1.2 becomes multiplying factor. So 200 into 1.2 gives you 240. 240 into 1.2 will give you 288. Okay. Are you guys getting this? Because this 1.2 is what we discussed in percentages, that when you have addition of 20% of something to the original value, you multiply it with 1.2. If the rate had been 10%, this factor would have been 1.1. So 240 into 1.2 will give you 288. Okay. So this is how the interest will also have the same multiplying factor. Okay. Now, some of you must be wondering that it's always easy to do the formula, which is A is equal to P into 1 plus R upon 100 raised to N. So in this case, that will be 1000 into 1 plus R upon 100, that is going to be 1.2, and 1.2 cube. So I know 12 cube is 1728. So I just need to get rid of the decimal points. So answer will be 1728. Yes. So this is of course one way. I was just explaining how the interest and amount, the pattern that they will follow. Okay. So let's go to some of the questions on compound interest. Oh, before that, two quick things: semi-annual compounding and quarterly compounding. So in case of annual compounding, you are calculating interest at the end of every year and then adding it to the principal to get amount, which will be principal for the next year. So in case of semi-annual compounding, what happens is the compounding will happen after every 6 months. Okay, so after every half year, you will be calculating. So the only thing that you need to do in such cases is the formula that we have, the original formula. So now just remember that instead of 1 year, you're calculating after every 6 months. So the time frame doubles. So when you have raised to n in the original formula, it will become 2n. And the rate of interest will become half. So whatever rate you had, divided by 2 and keep the rest of the formula as it is. So A is equal to P into 1 plus R by 2 divided by 100 raised to 2n. N will double. In case of quarterly compounding, so 1 year is divided in 4 quarters, which means that to calculate this, you will have, so basically compounding will happen at the end of every 3 months. So every quarter you will compound, you will calculate interest. So this will be R divided by 4 upon 100 raised to 4n. The time frame will become 4 times now. Now, generally, you will not find questions on semi-annual and quarterly compounding. In case a question comes on semi-annual, you will not have n more than 1 year. Okay, very rarely you will have n is equal to 2, because it involves finding something raised to 4, which may or may not be easy depending on the value of r. You will definitely not get a quarterly compounding question where n is 2, because then it becomes raised to 4n, which is raised to 8, and you will not have those questions. So just try a few questions on semi-annual, quarterly compounding, but it's not very important from the exam point of view. very rarely you will find a question on this. But you need to remember the formula, you need to understand how it works. Try to solve this. Okay, I can see a lot of you have answered 8820. And here also, there are two ways of finding this. Now, either you use the formula straight away. So, A is equal to P into 1 plus R upon 100 raised to N, which in this case is going to be, so A will be 8000 into 1 plus 5 by 100 raised to 2, right? So this is 105 by 100, which is nothing but 21 by 20. So the final answer is going to be 8000 into 21 by 20 into 21 by 20. And whatever you get as the answer, that is fine. So you can calculate this and get your answer. Uh, Another thing that you can do is, now you find what will be the interest for the first year. Okay. So I'm not solving this. I will definitely get the answer. It's simple calculation. What I'm going to do is, instead of using this method, I will show you another method that you can do. So you have 2 years, but compounded annually, and rate of interest is 5 years, 5%. So in the first year, right, I'm going to get 5% of 8,000, right? So 10% is 800, 5% is 400. So 400 rupees is the interest for the first year. Okay. And now we know the pattern that we saw some time back. We just need to find what will be the interest for the second year. So I just need to find 400 into 1.05. Okay. So 400 into 1.05. I just need to find 5% of 400 now and then add it. So 10% is 40, 5% is going to be 20. So 400 into 1.05 is 420, right? So 400 rupees is the first year interest, 420 rupees is the second year interest, and summation of this is going to be 820. We started with 8,000 rupees, so just put 8 next to it. 8820 will be the final answer. Okay. This is what you can do. You find interest of the first year, multiply it with the factor that you have, because rate of interest is 5, so it becomes 1.05. Get the interest of the second year, and then 8820 will be your final answer. So this is one method that you can use to save time. So Akash is asking which method do you follow in exam for saving time. It depends on the question, first of all, whether you can actually calculate the first year, second year, third year quickly by doing the second method that I showed. Sometimes it is better to use this method. So it completely depends on the values that you have. Sometimes you have really bad values, and using this formula may not make sense in that case. So instead of 5%, if I give you something like 14%, I'll not use this method, maybe, because then it becomes 1.14 square. So though I know I can find it something like 12996, so I don't really want to get into that. But you can use any of the methods. As long as you're fast at calculation, you should be able to answer in pretty much the same time. But having said that, in this case, this method is definitely better. You find interest first year, second year, add it, and add it to the principal to get the final amount. Okay, let's look at the next one. Okay, I think most of you got it right. It's 400. Now, see, if you have options, so I haven't given options to you, but if you have options, quickly you can eliminate anything which is more than 420, because simple interest is always going to be less than 420 in this case. Uh, so simple interest will always be lower than compound interest if the time period is more than 1 year and all other things remaining the same. So for first year, it will be equal. For all the other years after that, your CI will definitely be more than SI. Okay. So anything which is more than 420 can be eliminated straight away. Now, another thing that you can do is, now this is 420, right? So had this been SI, both the years would have been equal, and you will get somewhere around 210 as the interest of the individual years. So I'm just saying that if this had been SI, you would have got almost the same interest every year. So it would have been close to 210. So now what I'll do is I just need to find a number which is close to 210, which if I find another 10% of it and add to it, I'll get 420 as the answer. So close to 210, I have 200. So if I have 200, 10% of 200 is 20. So 200 and 220, the summation of which is 420. So that's how I can get that, okay, for the first year, the interest was 200. Now, this is something that you'll have to practice to get better at guessing what the interest will be. It will take some time, but then once you practice, then it becomes very easy. So you find half of this because it's 2 years. If it had been 3 years, I would have divided it by 3. I got 210. I'm trying to find a number close to 210. And if I find 10% of it and add to that number and take summation of everything, I should get the total interest. So that's how I got 200 as the interest for the first year. And this is happening at 10%. So 200 is 10% of 2000. So 2000 is my principal. Now you need not find the principal actually in this question, because if you know this 200. So in the table that we saw, the SICI table that we looked at, it will be something like this, that you have first year, you have second year, you have SICI here, 200 in the first year, 220 in the second year. If it is 200 in the first year here, it will be 200 here. If it is 200 here, it has to be 200 here. So that's how you get 400 and 420. So that is another way of solving this question. Nothing wrong with finding the principal and then finding the actual simple interest, because it's just 10%. So 200 into 2, 400 as the final answer. So SI will be 400. Okay, let's go to the next one. Now, of course, there's another method to solve this, which is the formula method. So if you are using the formula, A is equal to P into 1 plus R upon 100 raised to N. Now, amount is nothing but principal plus interest. So they have given you 420. So P plus 420 is equal to P into R is 10%. So 1.1 raised to 2, which is going to be 1.21. So 1.21 P is equal to P plus 420, and then you solve for P. So that is another method in which you could have solved this question. Okay, that brings us to another concept, which is a straight formula. You just need to remember the formula, and the only thing that you need to remember is that it works for 2 years. Okay, so whenever the time frame is 2 years, and you're supposed to find difference between the simple interest and compound interest, you can use this formula. The formula is difference is equal to P into R square upon 100 square. Okay, or P into R square upon 10,000. That is the formula. Now, if you want to find, so let's solve this question. So what they have given is, what will be the difference between the simple interest and compound interest on a sum of rupees 985. So principal is 985 here, and rate of interest is 10%. So 10 square is what we will have to find. Divide this by 100 square. So 100 into 100. And simply this will cancel now. So 10, 10, 100 is out. 985 by 100 is going to be 9.85. So your final answer that's the difference between simple interest and compound interest, is going to be 9.85. I'll quickly tell you how you derive this formula. So in case you want to just make a note of it, when you have 2-year time frame, you have A is equal to P into 1 plus R upon 100 raised to 2. And so this will be for CI. And for SI, for 2 years, the amount is going to be principal plus PN R by 100. So in this case, N is 2. So it will be 2PR by 100. So on one side, you have P into 1 plus R upon 100 the whole square. And on the other side, you have this. You just need to find the difference between this. So if you solve this, the 1 plus R upon 100 whole square, if you expand this and solve, ultimately you will be left with P into R square upon 100 square. So that's how you get the formula. The P and 2PR by 100 get cancelled. Okay, but you need not remember the derivation. Just remember the formula P into R square by 100 square. Try this. Oh, all of you are getting 12. So good. Now let's see how we can do this. So they have given the difference now. So P into R square upon 100 square is the formula, is equal to difference. So the difference is 72. Your principal is 5,000. R is something that we need to find. And then you have 100 square in the denominator. So that is 100 into 100. So if I solve this, I can simply cancel this. So 50, this will be 2. So R square will be 144, and hence R will be 12. So that's how we'll get 12 as the rate of interest. So very simple thing. Don't just remember this formula, because there are a lot of cases where people struggle and they sometimes mess up these questions. But PR square upon 100 square, simply remember this. It will definitely help in some or the other way. Now we'll see another quick technique, but before this you need to understand the meaning of the sentence, a sum of money. So this is a different question and a different concept altogether. We're done with the difference between SI and CI for 2 years. So you'll see a lot of these questions that a sum of money becomes 7 times in 4 years or whatever, n times in X years and so on. Now, in how many years will it become whatever, 19 times in this case? Now, when you say that a sum of money, let's say I'm just giving an example, a sum of money becomes 3 times. Okay, I'm saying a sum of money becomes 3 times. What do you mean by this? It means that the amount at the end of whatever period is 3 times the original principal. Okay. Now I know that amount is nothing but principal plus interest. So in this case, it's going to be P plus I is equal to 3P, which again means that interest is 2P. So when you're talking about simple interest, and you're saying that a sum of money becomes n times, or might get confused with n. So let's say a sum of money becoming k times, it essentially means that the interest that you're getting is k minus 1 times the principal. Okay, so that is something that you'll have to remember, that a sum of money becoming k times means that the interest in the period is nothing but k minus 1 into p. Okay. Now, which brings us to this question, that a sum of money becomes 7 times. So 7 times, for it to become 7 times, the interest has to be 6 times principal. Okay. And this is happening in 4 years. In how many years will it become 19 times? So for it to be 19 times, the interest has to be 19 minus 1, 18 times the principal. Okay. So if 6p happens in 4 years, 18p, which is nothing but into 3, this 4 needs to be also multiplied with 3. The answer will be 12 years. So it will take 12 years for the sum of money to become 19 times. Okay. Now there is another quick technique in which you can solve this question. So 1 becoming 7. So something becomes 7 times in 4 years. Okay. You take the difference between this 1 and this 7. It is 6. Okay. The question is, in how many years will it become 19 times? And this is happening at simple interest. Okay. So 19 times. So again, take the difference. The difference is 18. 6 into 3 gives you 18. So 4 into 3 will give you 12 as the time frame. Okay. Is the method clear? The understanding how it works, and the shortcut is of course very straightforward. You take the difference. So in case of SI, if you're using this technique, take the difference between the numbers that you've written. Okay, good to go. Should we go to a question you want to try? Okay, so let's go to the question. Just try it. Yeah, I can see a lot of you answering 80 immediately. So let's look at the method that we did. 1 becoming 11 times. So the first thing that you need to understand is whether it is simple interest or compound interest. So we'll come to compound interest question. If it is simple interest, 1 becoming 11. So difference is 10. I need to find when 1 will become 101. The difference is 100. So 10 into 10 gives you 100. So whatever time frame this takes into 10 will be the time frame that I need for this to happen. So that's how you'll get 80 years as the answer. Okay. So simple interest, take the difference, find the multiplying factor, and then multiply the original time frame with it to get the final time frame. Okay, so this was simple interest. Now let's look at, so things are a little different when it comes to compound interest. Okay, so read the question first. A sum of money becomes 3 times in 5 years. In how many years will it become 81 times at compound interest? Okay. Now in this case, what you need to understand is if you were to solve this without using any shortcut, by knowing the simple concept, amount becoming 3 times is nothing but 3p is equal to p into 1 plus whatever r upon 100 raised to 5 in this case, right? The question is, in how many years will it become 81 times? So 81p is equal to, again it is going to be p into 1 plus r upon 100 raised to something, right? Now if I just divide these things, I can eliminate, first of all, this p can be cancelled, right? So I'm left with this. So 3 by 81 is what I need to know. So this is, if you try and understand this, uh, you need to find the power which is there for 81. Okay. So in this case, the shortcut that you have, so you can solve this from here and you'll get the answer. But I'll give you the shortcut that you can use. So 1 becoming 3 in 5 years, right? Now the question is 1 becoming what? Becoming 81 in how many years? So just find what power is this number of this number. So 3 raised to what gives you 81. Okay, so 3 raised to 1 is 3, 3 square 9, 3 cube 27, and 3 raised to 4 is 81. Okay, so that gives me 4. You just need to multiply the time that you have, 5 years, into 4. That will give you 20 years as the answer. Okay. So look at this number, and try and find what power this number is of this number, and straight away multiply what you get with this time frame. Okay. We'll come to the next question because you can practice that and then see if you get it right. Just as a side note, just remember powers of 2. So 2 raised to 1 to 2 raised to 10. Just try and by heart this. So 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. So you just need to find where 500, what power of 2 is 512. So 2 raised to what gives you 512. That will give you answer as 9. So 9 into 6 is equal to 54. So in 54 years, it will become 512 times. So if in this case, instead of going like this, if you just remember 2 raised to 9 is 512, that will be great. If you don't, then at least remember 2 raised to 10 is 1024. And then you can reduce 1 power and divide this by 2 to get 512 as 2 raised to 9. Okay, let's go to the next one. Okay, so Akash is asking, can you do this with conventional method? So I'll just show you how you can do it. Now, so becomes 2 times in 6 years. So 2p is equal to p into raised to 6, and 512p is equal to p into 1 plus r upon 100 raised to whatever, let's say k. Now, if you cancel this, you get this as so 1 plus r upon 100 raised to 6 is equal to 2. Okay. Now this 512 has to be represented in the form of 2. So 2 raised to 9 is equal to 1 plus r upon 100 raised to k. Right. But then 2 is nothing but 1 plus r upon 100 raised to 6. So 1 plus r upon 100 raised to 6, the whole thing raised to 9 is equal to 1 plus r upon 100 raised to k. Okay, we could have simply taken 1 plus r upon 100 as something like m to make it simpler. But then this 9 into 6 will continue to happen. So that will give you 54 as one power, and that will correspond to k as the other power. So that gives you 54 as the answer. It's nothing but the same thing, but you always use the shortcut because then you need not write all these 1 plus r upon 100. Let's go to the next one. So this is another concept. So you'll see a lot of questions where they will ask you that the number of years in which a sum of money put at some rate of interest will be doubled or more than doubled. Okay. So in this case, when they're saying more than doubled, it means it has to just cross the double value. That's the meaning of the question. So rule of 72 is nothing but it gives you the time or rate of interest at which a sum will double at compound interest. Okay, so if the rate is given, you do rate is equal to 72 by time. If time is given, you do 72 by rate. Okay. Now understand that this gives approx value and it doesn't give you the exact value. Okay. Now in this case, what you are doing essentially that a sum of money is doubling, which means 2p is equal to p into 1 plus r upon 100. So in this case, r is 20, and you need to find n. So I'm just replacing r with 20. So P will cancel, of course. So what you're trying to find is 2 is equal to 1.2 raised to what? And if you actually use the calculator that you have, you will get n, the value of n, which will be very close to the value that we are going to get by this calculation. Okay. So the calculation says that you divide whatever is given to you, the divide 72 by whatever is given to you. So in this case, you are given rate of interest, which is 20. So 72 divide this by 20. Okay. You get what? 3.6. So in 3.6 years, okay, the money will double. But this is again, as I said, approximate value. The question asks the least number of complete years. Okay, so it has to be, what will be the answer? Will it be 3? No, because if it is 3, then it will not be double. And it has to go beyond that. So that's why it says more than double. So the final answer will be 4 years in this case, because 3.6 is when it will actually double. And then since they're asking the least number of complete years, we'll say 4. So just remember, if rate is given, rate is what you're supposed to find, divide 72 by the time. And if time is given, divide 72 by rate. So just remember 72, the rule of 72. So I'll just quickly give you a question. Let's say, what should be the rate of interest if in, let's say, 12 years, the money is getting doubled? Yeah, everybody is getting 6 because it's so straightforward. Whatever quantity, whatever value that you have, you just need to divide 72 by that, 72 by 12. So in if rate of interest is 6%, in approximately 12 years, the amount, the money is going to double at compound interest. Okay. Vivek is asking whether this is applicable only when money is doubled. Yes. Okay. So if you are remotely interested in finance, do definitely Google for rule of 72 and other approximations of rule of 72. So as I said, rule of 72 is still, it is giving you an approximate value, but there are other things that you can do. So I think there's rule of 69 as well. There are some limitations of these approximations, but if you're, again, as I said, if you're interested, definitely check it out. Okay. But from exam point of view, just remember rule of 72 at least. Let's solve a few miscellaneous problems and then we'll stop. Oh, okay. I think this is what we already solved. Yeah. Try this one. Okay, so I can see three of you have answered this. Find the rate at simple interest at which a sum becomes four times of itself in 15 years. Okay. So if we use the simple interest formula straight away, as we discussed in when we were discussing that trick of reducing 1 year, when we say a sum of becomes four times, whenever we read this, what should strike you is interest is equal to 4 minus 1, which is 3. So 3p is the interest. So the formula will be nothing but PNR into PNR by 100 equal to 3p, because that's the interest that you're getting. And p will of course cancel out. They have already given time frame, which is 50. So this is 50. So 3 ones are 3 fives are, and 100 by 5 is 20. So R will be 20. Okay, very simple, nothing difficult here. Let's look at the next one. Okay, I can see some three or four different answers. Okay, so I don't know what method you guys are doing, but then this question is not that difficult. So don't waste your time finding the. So don't. So interest you can find. So 156 is the interest that you're getting for 3 years at certain rate of interest and so on. So you can find 156 is for 3 years. So 52 is for 1 year. So then 52 by 800 will give you rate of interest, and then you add 4 to it. Then you again find. So that will of course give you the answer. But the only thing that you need to know is in this case. So you are increasing the rate of interest by 4 years. So this 4% increase is going to make whatever difference that you will see. So instead of finding everything, I have 800 rupees, right? The rate of interest is increasing by 4. So into 4, time frame is 3 years. Divide this by 100. What you get here is 4 these are 12, 8s are 96. So this 96 is the incremental value, which is over the increase that is already there. So what they have given at a certain rate of interest, and if the rate increases by 4%, this is what the incremental will be. So when you have whatever rate of interest, 800 is becoming 956, right? Which is increase of 156. But 156 plus 96 is what the increase will be now, because the rate of interest is increasing by 4, which means it is going to be 252 as the increase. So 800 plus 252 1052 will be the final answer. So this is one way of calculating this. Now, how do you get this shortcut is you need to understand that the rate of interest increase is what is going to impact this. Because otherwise, if you solve this, you will probably do something like this. So 52 by 800 into 100. Because 956 minus 800, which is 156. 156 for 3 years. So 156 by 3 is 52 for 1 year. So 52 on 800. So that will give you, this is 8. So 6.5. Increase of 4. So 10.5 as the new rate of interest. So this is where the difference lies. That 6.5, 10.5, the 4%, which is what I'm directly taking here and solving. Because this and this is not changing. So that allows me to do the shortcut. Otherwise, I can, of course, I can do 800 into 10.5 into 3 divided by 100. That will give me interest and then add it to 800 to get the answer. So nothing wrong with the method, but it requires more calculation, whereas this can definitely make your life easy. Okay, so just to explain again, this was the difference. These things are remaining constant, so I can use it straight away. I get the incremental interest. Incremental interest needs to be added to the original interest to get the final interest, and that needs to be added to the principal to get amount. Okay, let's go to the next one. Okay, I can see most of you have seemed to got how to solve this question. So you got 64.1 as the answer, which is right. Quickly, let's look at how you can solve this question because there are two ways in which you can do it. Now, first is to use the normal formula method, right? So if I do this, A is equal to, I'll find the compound interest first because simple interest is very easy here. P is 1000 and 1 plus R upon 100. So 10%, I'm not writing 1 plus 10 upon 100. It's understood 1.1 raised to 4. So this is one way in which we can solve this question. So 1.1 raised to 4 is very easy. So if you were there in the speed calculation session, then you will know this. But if you haven't seen it, then do definitely watch that session. So 1.1 square, so 11 square is going to be 121. You'll have two decimal places shifted. 121 square is going to be, so I'll quickly tell you. So 121 into 121 if you have, plus 21 plus 21. This method is explained in that video. So just watch that video again. 441. 121 plus 21 is 142. This 4 goes here. 14641. will be the final answer. So that is square of 11, 11 raised to 4. But that is what we don't want. We are looking at 1.1, so we have to shift 4 decimal places. So this will be 1000 into 1.4641, which will give you 1464.1 as A. So this is this is at compound interest. Simple interest is of course at 10% on 1000 rupees, so 100 rupees per year. So it's going to be 400 rupees. So 400 for simple interest. Compound interest is this part because you're subtracting 1000. So 464.1 minus this, which will give you 64.1. Now, again, you can, if you know the concept of Pascal triangle, also you can find this. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and 14641, which is the value of 11 raised to 4. Also a good idea to remember it in case it comes. So that gives you 64.1 as the answer. So this is one way. Is there any other way? Yes. So what we did when we solved some of the earlier questions and we discussed concepts, every year the simple interest is going to remain the same. So for 4 years, this is how my simple interest will look. My compound interest for the first year is going to be 100. The next year, it's going to be 100 into 1.1. So 110. 110 into 1.1. So 121. 121 into 1.1. So 133.1. Okay, this at least you need to remember. So 11, 11 square, 121, 1331 is 11 cube, and so on. Now I just need to find the difference, right? So I'll find the difference between SI and CI every year. So SI CI difference here is 0. SI CI difference here is 10. Difference here is 21. Difference here is 33.1. The summation of this is of course 64.1. So this is another thing that you can do in such questions, because see, these are some of your differentiators, because a lot of people will look at this question and they'll say, I don't know how to calculate 4 years, because there's a formula for 2 years, right, which we discussed. But since a lot of people will leave this question, it becomes a differentiator. If you solve this, you are getting an edge over others. Yeah, that brings us to the end of the session. So we discussed the concept of simple interest, compound interest. We discussed semi-annual, quarterly compounding. Finding the difference between simple interest and compound interest when the time frame is 2 years. Then we looked at 2 shortcuts about a sum of money becoming n times at simple interest as well as compound interest. And we solved a few miscellaneous questions. So if you have any doubts regarding this chapter, feel free to put it on the Facebook group that we have, or I'll be adding everybody to WhatsApp group. I think some of you are already there on the group. Those who have recently joined, maybe yesterday or today, they'll not be there on the group. In case you're not there, I'll definitely add you by tomorrow. And if you have any doubts, if you're solving something, you can just click a picture and then send it on the group and we'll get back. So there is one more thing which is there which I didn't discuss, because first of all, it's very rare that you will get those questions, which is installments at simple interest and compound interest. So what I would like you to do is go to Learning Roots website, so www.learningroots.in. Use the search function and just search for installment, and you will get an article on which is installment at simple interest and compound interest. Just go through that article once, and that should be enough. If you get some difficult question on SICI at installments at SICI, in the exam, it's better if you leave that question straight away. Don't waste a lot of your time, because these questions involve a lot of calculation. So if you can make a guess, educated guess, yes, definitely go ahead with that. But if you can't do that, not a good idea to even try and solve that question. But still, I would suggest just go through that article once. If you don't understand it, let me know. Whenever we have the next session, I'll probably explain it for another 5 minutes or so in the beginning. But the article is pretty self-explanatory. But yeah, just go through it in case you encounter an installment question. But again, as I said, very rare. So that's it from my side for today. And I think you have a verbal session tomorrow. So, okay, that's it. Goodbye.